Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
And this IP address would be the gateway for this VLAN computers. Correct? Okay, so close it. So this is the gateway. Similarly, this IP address would be gateway for this VLAN computer. Now, whatever sub interface which we have configured, here we configured switch virtual interfaces. Okay, sorry. So I would say control copy. I will go to this computer. I will say paste, close it, paste, close it. Okay, done. Now let's check. Now there is one command which we require to execute, but before that, let's check ping 192.168.10.100. Okay. Now they are trying to do inter-VLAN routing. Now, do I require any kind of trunk port? Now I'm not connected to the router. My router is actually a switch. So I don't require to configure anything. Okay. So the missing thing is we need to enable routing over here. So if I go here config T, I will say IP routing command, exit, show IP route. So both the route should be visible. Now if I go to the computer and if I try to ping it, it should send me some reply. So, okay, it's working. Correct. If I go to this computer and try to ping to 1.1, it should also send me so both are absolutely working fine. So this is called as inter-VLAN routing with layer 3 switches with SVI. Correct. So this is I'm going to communicate with different type of VLANs and I'm able to communicate with these two networks and everything would be absolutely working fine. Correct? I hope till so far, is it clear to you? Any doubts in this? If you have any doubts regarding this, kindly tell me. Okay, now why we need to ping 172.16.5.0.5? Okay, now could you unmute yourself and tell me what exactly you want to ask me?
So before you're telling we need to ping 172.16.0.10, but you are thinking 172.16.0.5. So only I'll ask the question.
Okay, no, that is by mistake actually, because in my mind I was trying to think about 0.5 is my, because that is the way we are supposed to do in our environment. So I am doing this particular thing a long time. So that was a mistake. I'm supposed to type 172.16.0.5 because that is a interface IP address which I configured for IT. But by mistake, I was pinging 0.5. Correct?
Okay.
So this is mistake. So don't worry about that. I have to ping the IP address which is for interface which I configured. Correct? Here also I configured the interfaces, no doubt about it. But the only difference is the interface which I have created over here, I use that interface to do the routing. Correct? So this is very, very interesting method which we can use in order to communicate between different VLAN. Now I am not actually going outside. I am doing routing within the local area connection. Remember that. Okay. Okay. So now let's take a 2 minutes. Okay. Now next thing we are going to talk about extended VLANs. We are going to talk about extended VLAN. Now this is something which you required very huge environment. Now, if you carefully check our VLAN output, if I say, okay, if I go to any switch, okay, and if I say enable show VLAN, okay, if you look at this output carefully, you will see from number 1 to number 5. Okay, these all VLAN which we can create on a single switch. Correct. So the total number of VLAN which I can create, correct, which is a normal VLAN, we can say from number 2. Okay, VLAN 1 is already occupied, which is a default VLAN, but from number 2 to the number 1001, we can create a VLAN as per the output you can see here. Now number 2002 is occupied, 2002, 2003, 2004, 2005. Correct? This is for your WAN actually, so we cannot create it. These numbers are already occupied. So any number in between this is called as Ethernet VLAN. Correct? What we can call it as Ethernet VLAN. Remember that. So number 2, now we have created how many VLANs? 3 VLANs. What is the ID? 300, 400, something like that. Correct? So these VLANs would be considered, if I create any VLAN ID in between these two numbers, would be considered as Ethernet VLAN. Correct? Agree? Yes, we have seen it. We have created it. No problem. After that, my Cisco switch is saying me 1002 to 1005. These are the VLAN which is created for FTDI ring. Now this is a WAN technology actually, okay, which is no more we are using it, but still these numbers are actually fixed, means you cannot do anything. Correct? These numbers are fixed. This is correct. Now let's see from 2 to 1000. Whatever VLAN ID which we are creating some number, correct? By default, if I'm using this particular VLAN number, by default, it uses 10-bit address space. This is a 10-bit VLAN ID. So if you are going for 10-bit VLAN ID, so how many maximum VLAN we can create? The maximum VLAN which we can create with this VLAN ID is 2 raised to 10. That is nothing but 1024. Correct. So if I'm using any VLAN number in between these series, it uses the VLAN ID. The size of the VLAN ID is a 10-bit, and the maximum number which I can go, it's 1024. So this is a maximum number which is supported by this 10. But what if I want the VLAN ID to go beyond that? Okay, if I say, if I try to create it, let's see what will happen actually. Is it going to give me any error? If I say VLAN 400, or you can say 3000. Okay, you can see the VLAN create is filled. Okay, and it should be extended VLAN. Now, if I talked about extended VLAN, so extended VLAN actually start with the number called as 1025 to 4096. This all series would be called it as extended VLAN. Now here our standard 802.1q standard say they are using 12-bit of VLAN ID. Whatever VLAN ID which they are creating, that is a 12-bit of the VLAN ID. Correct? So the maximum number, if I would like to go for an extended VLAN, now you can see here there are some rules and regulation. Now here it is not allowed in a current VTP mode. Now VTP is a protocol which we are using for some automation. It is called as VLAN trunking protocol. Okay, so if I'm using any VLAN trunking protocol, then whatever mode which we are using right now, that mode is not compatible for your extended VLAN. Now what mode is available right now? If I say show VTP status, okay, we will cover VTP, don't worry about that. Now current mode is off. Now if my VTP mode is in a server mode, then extended VLAN we cannot create it. Either I need to turn off this mode, or you can go for a mode called as transparent. So if I say conf t, okay, okay, PTP mode, I don't know whether it's possible. Okay, yes, transparent mode is there. So if I want any particular extended VLAN to be created, that mode has to be transparent. Correct? Now, if you have a mode transparent, then only my extended particular VLAN should be created. Okay, so if I change the mode to transparent, okay, that's fine. I will exit out of it. Show VTP status. Now this is mode is transparent. Now am I able to create any VLAN like an extended VLAN? Conf will say VLAN 3000. Yes, now it is possible. Correct. So remember,
Hey viewers, our Master in DevOps engineering program can help you to hone the skills necessary to succeed in high-level DevOps positions. So, what are you waiting for? Enroll now and earn certification that show you are keeping pace with today's technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
whatever VLAN which we are using, which is in between 1, or you can say technically speaking from 2 to 1001, it would be considered as a Ethernet VLAN, and it use a 10-bit of VLAN ID. So the maximum supported VLAN number should be 1024. Correct. After that, 1002 to 1005, this VLANs we already use for FDDI technology. Don't worry about that. We are not using it this technique at all. And currently, make sure that this particular technique and this particular VLAN IDs won't affect anything at all. After that, what is the maximum I can go? 1024. But if I want any more number of VLANs to be created on my switch, then I use the technique called as extended VLAN. However, there are two different rules. We have seen only one rule, that your VTP has to be transparent mode. By default, your VTP was in a server mode. We have seen that. We converted that mode into the transparent, then only it allowed me to create any VLAN whose size is actually getting 12-bit. Correct? See, this is very important if you want to create huge number of VLAN in your organization. Then only we are using the technique called as extended VLAN. Remember that this is very important technique which we can use it. However, for a smaller and medium scale network, to be honest, we are not creating too much 3000 4000 VLAN. It's not technically possible, but in internet service providers network, yes, it is possible. Correct. This is very important in order to create more than your virtual LANs in your environment. Correct. But for your information purpose, it is very important that yes, this is the logic behind it for your extended VLAN. Correct. Now we have covered almost everything. We have covered extended, we have covered print tracking, trunking, dynamic VLAN, what you know that. Now we need to cover two important concepts called as voice VLAN, native VLAN, VTP. Correct. Inter VLAN routing we have already seen it. Correct. Now let's understand voice VLAN. What is a voice VLAN which we can use it? Correct. Okay. Here. Okay. Now typically voice VLAN use in order to carry voice data. Now majority in our organization, we do have a phone which is completely IP based phone. Correct. Now whatever IP based phone which you guys are using, we are also managing those phone with the help of VLAN. However, whatever VLAN we have seen till so far, that we can call it as data VLAN, because that VLAN can handle the data. Correct. That would not handle your actually voice. It will handle our normal day-to-day data which we can use. Correct. But in voice specifically, we have a dedicated VLAN who can control VoIP services, correct? I can transmit the voice data with a different VLAN. I can transmit your data with a different VLAN. Now, this is the only VLAN where we can apply a single port, a single physical port into a data VLAN as well as a voice VLAN. I told you it's 1:1 mapping. If your data VLAN is the part of one VLAN already, you cannot use the same port to other VLAN. But here the conditions are changed. Here what we are doing, a single port would be the part of two different VLAN. However, both the VLANs are different. One is a data VLAN and second one is a voice VLAN. So this is only possible in this situation where I want to change both the things together, data and voice, correct? And I want to transfer your voice and data on two different VLANs. So in that condition, I am going to do this, correct? Now understand how we can practically configure the voice VLAN. Okay, so I have a small idea or a small thing which we can use it. We don't require a router, but still I will tell you how we normally use it. We do have a telephone series router over here. Okay, this is our IP telephone series router 2811. It does have a module for telephone. That's why I took it. Otherwise, we are not configuring telephone. If the time permits, we will do that. Otherwise, we will not. Okay, just a moment. Okay. Okay, sorry, I was just having a water. Okay, so let's take this router. Now this is a telephonic router and I'm going to connect a switch. Now I'm just giving you the idea. Now voice VLAN is not the part of your curriculum, that nobody is going to ask you the question on it. It is a part of your curriculum, but not as a part of the certification, because there is a complete different certification for VoIP and complete different work. Now, normally I worked as an administrator in data centers, so we are coming across in many situations like this where we need to deal with this type of device. Now I believe this is our telephone. No, this is an analog telephone. This is not. We are going. font or IP font. Yeah, this is the one. Okay, this is the IP font. This is the IP font. I will tell you three different way how these things can be configured. Okay, so let's connect the wire router to switch. Router really don't require it, but still for our topology, I have doing it. Now look at here carefully. Okay, I am connecting one computer, one phone, but here what I'm connecting, how I'm connecting it. With the help of this wire, I will connect it over here. And from this telephone, I'm connecting my computer. Correct? So here I can understand, I can have only phone connected. So my only voice data can be transferred. Here I can understand only data would be transferred through VLAN. But here you can imagine I have a single port which I'm connected through this, and I'm connected computer this. So data is also traveling and phone voice is also traveling. Correct? I need to turn on this phone power modules. I need to turn this phone on. Okay. Okay, so this is how I need to turn on this phone as well. This is a power module. Okay, so let's understand how to create a voice VLAN. Okay, and how a single port. Now this port, interestingly, port number, I believe I will take a small, okay, port number 4. This particular port is a part of voice VLAN as well as the part of data VLAN. However, both the traffic would be available from same port, but both are differentiated. Okay, so let's go to the switch. Let's go to the command prompt. Now let's say we are going to create a VLAN 10 for data. VLAN 50 for voice. You can give the name like that. Okay. So this is how we are going to do it now. So if I go to switch, I will go to enable and I will go to the config T. So my VLAN 10 is for data. I will say VLAN 10 is for data. I just give the name. This is for a data. Okay. So I'm not particularly saying that I'm telling him this, that data should go on. This is a normal VLAN. I can give any name. I just gave the name like a data. So VLAN 10, I would say this is made for data traffic. Correct? Now I would like to create a voice VLAN. I will say VLAN 50. There is no change to create a VLAN. Remember that. Don't worry about that. Name is voice. Okay. Exit. Okay. Now if I go to exit, if I say show VLAN brief, I would be able to see both the VLANs over here. Correct? So to create a VLAN, it's nothing, it's the same process. Correct? Now, if I would like to take this particular computer into my VLAN, which is called as VLAN data, what I normally do, this is a port number 2. I will go to conf interface fast ethernet 0/2. what I will do, switch port mode access, switch port access VLAN, what is the number? 10.
Hey viewers, trying to get into DevSecOps? Enroll for our DevSecOps certified professional programs and earn the certification that shows you are fit for these technical roles and requirements. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Now look at here what I'm doing with the phone. Okay. Now phone is connected on which port? Is connected to the port number 3. Okay, I will go to the port number 3. Interface fast Ethernet 03. Now this is the only difference. Okay, switch port, do the question mark. Do I have a voice option? Yes. Okay, type voice. Correct. Then he will ask me, give me the voice VLAN you want to allocate it. Means VLAN is same, but I'm only diverting the voice traffic to a specific VLAN which I have created. Correct. So I will say VLAN 50. Enter. I can say switch port mode access for this particular port as well, because end of the day it is an access port. The telephone is connected to that particular port. Correct. So I done that. Now look at here, because here both are connected. The data is for computer and voice for my telephone. So let's go here. This is a port number 4. So I would say exit interface fast Ethernet 0/4. First of all, say switch port mode access, switch port access, okay, VLAN 10. Now this is I'm allocating port number 4 for data VLAN to transfer the data. Correct. Now on the same port, I will say switch port voice VLAN 50. Correct. Exit out of it. Exit out of it. Show VLAN brief. Correct. You can look at the things carefully now. The port number 4 is available in data. Port number 4 is available in voice as well. Correct? But if I try to do with the data, data will not allow any particular port. If it is a part of a single VLAN, he should be the part of that VLAN only. He should not be the part of other VLAN at all. Correct? So understand, this is the difference in a voice VLAN. Voice VLAN would be treated completely different way. I'm connected both the things with the single wire. There is no double wire. Here I can say this is only data, this is only phone. But here I'm connected a single cable between all these two devices to the switch. But whenever they are transferring the data, they are transferring the data with two different VLAN ID. It is completely different way they are going to handle it. Correct? So this is called as voice VLAN. Correct? Now the last part which is required to understand, what is a native VLAN. Correct? Now this is very important. The last thing in VLAN which you should know, it's called as native VLAN. What is a native VLAN? Correct. Now native VLAN is the VLAN which is considered by a switch. Now I will give you one example. Okay. Let's say I will connect okay. Okay, two devices would be fine. Okay, I will explain you what exactly the native device could do. Okay, this is my hub. Okay. Okay, so if I have any such scenario, and maybe I have a router in between, so we don't worry about it. So if I say I connect the switches together, I will say this switch is connected here. This is a backbone switch. So where I connected all the switches and the traffic will come here. And I do have one of the devices called as hub. Okay. And I do have a computer over here. Okay. Now let's say I do have something like this scenario. Correct. Now, what is the problem in this scenario? The problem is very much clear that this middle device is problematic for me. Let's say if I'm sending some traffic from this switch, for example, okay, let's say there is a computer over here, and this computer is connected to this switch, correct? Now this computer is sending the traffic over here, and he's sending the traffic over here, correct? And let's say I do have a VLAN configured. So my both the switch will be able to find out the concept called as VLAN trunking, and they would be able to do everything with the help of that particular trunking protocol. They are binding the VLAN frame and tag that frame with VLAN ID. They can remove that frame before it send it to the client, because switch is understanding the VLAN concept. But what if I'm sending the traffic to this device? Now this is hub, which is, I told you that, which is a very basic device. It does not understand what is the meaning of VLAN, correct? Now imagine some traffic is coming from this computer to this hub. Hub only broadcast everything, and this broadcast traffic going here, correct? Now how come this particular switch will understand where should I forward this traffic, which VLAN? Because he's supposed to read the tag of the VLAN, but currently we do not have a tag at all, because hub don't understand the concept of the VLAN at all, correct? Now what we are supposed to do in such situation? Okay, now in such situation we are not supposed to do anything. Router by default do have a concept of native VLAN. Native VLAN considered to be a default VLAN, correct? Now you can see, simple, whenever the traffic comes here to here, this switch would be considered that this traffic is coming from native VLAN, and it should forward it to the native VLAN only. But who is native VLAN? Now by default my native VLAN is my default VLAN ID, that is number 1. Okay, if I go to any particular switch, okay, by default the native VLAN would be my default VLAN, which is VLAN 1. So imagine, now everybody know that native VLAN is by default number 1. So basically you have to change this native VLAN or a default VLAN to something else, okay? Because native VLAN is nothing but your default VLAN, which can be considered. So you have to change this native VLAN to some other number, because there is an attack called as Vlan hopping. When we discussed about n+, there is a security concept, and under that there is a concept called as Vlan hopping. If every world know that your native VLAN is 1, because that is the default VLAN, correct, then there is a problem. Correct. Now, why native VLAN is there? Because there might be devices in your infrastructure who don't understand the frame tagging. They don't understand the VLAN. So anything which I receive from here, or anything which I am sending, now while sending it, he does not do anything. He simply send the traffic to here. What he will do, he will broadcast it. What he will do, he will broadcast it. He will not do anything. And as per the switch, it could be like a normal access device. It is not a trunk port. Okay. So I will show you how to do it. Okay. Just a moment. Okay. Okay. Sorry about that. So understand how we can define this now. We really don't want this to be there, but let me delete this. Okay. Now, okay. Now, if I say, okay, I will create a VLAN over here. Let's try this topology. And okay. Now we need to understand what is the exact function of the native VLAN. Okay. So let's say this is text of 1, and I would say 168.1.100. Okay, that's fine. This computer should be in the same network, 192.168.1.200. That's great. Now, technically speaking, this should be the part of same VLAN, correct? But here I cannot create a VLAN. Here I can create a VLAN, but doesn't make sense. I will tell you why. Now, let's say it is connected to the port number 2. So what I will do, I will create a VLAN over here. Okay, configure T. I will say VLAN 100. I will say the VLAN 100 is made for a simple name is test. Exit. I will say interface fast Ethernet 0/2. Correct. And this is 2. Okay. I will take it to the VLAN 100. I will say switch port mode access. Switch port access. Sorry. Access VLAN 100. Correct. I will make this port as a trunk because he's carrying this VLAN traffic from here to here. So I just want fast Ethernet 1. And if I do it trunk over here, automatically other side would be trunk because of DTP, dynamic trunking protocol. Exit, exit, and oh, sorry, conti interface fast Ethernet 0/1. I would say switch port mode trunk. Okay. Now this port would become trunk. I will configure VLAN 100. Doesn't make any sense. Have any device connected over here? but still we should know configure that VLAN traffic over here. Now, if I try to make this port as a trunk, imagine what happened. This is connected to the port number 03. This is connected to path fast Ethernet to hub now. Now you can see I'm trying to configure this particular port as a trunk. Now DTP will not work because other device would not be a switch. It is a hub. So if I say fast Ethernet 03 interface fast Ethernet 0/3 switch port mode trunk. Okay, we done that, but he know that other port is not a trunk at all. Correct. Now if I go here and if I fire something, show interface trunk.
Hey viewers, are you looking for formal training on SRE practices? Take our SRE program. This course will teach you how to successfully implement site reliability engineering in the modern day 24/7 services. Kickstart your SRE training today. Contact info is mentioned in the video sidebars and in the description box. Book your seats for the upcoming batches now.
Okay, what is a native VLAN? So this trunk is receiving any kind of signals which is coming from non-VLAN devices. It will always configured. It would be the native trunk would be VLAN 1, and this is what our default VLAN. If I say this is the VLAN ID 1, correct? If I go to this switch, exit it, show interface trunk. He said also if I have received any particular traffic, correct? It should be, I would consider the native VLAN should be 1. So any hub is sending the traffic. He said this particular traffic is made for whom? It is made for native VLAN, that is a default VLAN, correct? Now if I go here and try to ping 192, oh sorry, 192.168.1.200. I'm trying to connect to this machine, correct? I will try to ping this 100 also. Ping 192.168.1.100. Is it pinging? No. The reason behind it, he's sending the packet to hub. Hub is sending the packet to switch. But switch say this packet is for what? Native VLAN. That is a VLAN 1. Remember that this is how it is happening right now. Why? According to the IP address, this computer and this computer are in the same range. No problem. This is 1.100 and this is 1.200. And I want this communication to be happened between these two. But what is the problem? Native VLAN is the problem. Problem means I send the packet to hub. What hub do? By default, he broadcasts the packet to the every port. Then the broadcast will come to this and it will receive to the switch. Whenever a switch receive this packet, he said it does not have any kind of VLAN ID at all because it is coming from hub. And this device don't know any concept like a VLAN. So what this switch will do, he will say, okay, then definitely it is made for native VLAN. Then what tag he is going to put? He is going to put the tag number 1 because this is what native VLAN is. Now this particular 100 computer, is it a part of native VLAN or is it a part of VLAN, the one which we have created? because we took this particular computer in a different VLAN, but he's sending the data packet to someone in VLAN 1. Correct? This is a problem of my native VLAN. Correct? So you need to understand, currently my computer do have 100 VLAN, and this computer is a part of this VLAN. You're trying to send a packet, but this switch, what he's doing, rather sending the VLAN ID 100, he's setting the VLAN ID which is available under native VLAN. Correct? Then what is the solution for this? Okay, always it is recommended to change the native VLAN. Okay, so that would be the great option which you can use it. But remember, if you change it on other only one switch, then other switch would get a problem. You have to change it to every switch. So if I go here and if I go to this trunk link, fast Ethernet 03, okay, so if I say conf t, I'm telling this interface that whenever you want to take the packet from hump, the native VLAN has to be 100, not 1. Okay. So I will say interface fast Ethernet 0/3. Okay, switch port, let me see, that option is available. Okay, trunk option is available. Do we have available the setting native VLAN should be 100? Right, now look at here. Now, there is one problem has happened. I will tell you what problem has happened. Show interface trunk. Okay, your VLAN would be 100 over here. This interface will take the packet. Now you have one more interface over here. So you have to configure this trunk interface also accepted. Otherwise, it will throw the problems over here. Okay, so sometime, okay, it's not yet done. Let's go to this interface, fast Ethernet 1, because this is also number 1 right now. So let's do one thing. Go to the fast Ethernet interface, fast Ethernet 0/1. We will change the native VLAN for this interface also. Now make sure that I'm doing only for trunk. Okay, so switch port trunk native VLAN 100. So I'm telling that my default VLAN is not 1 now, it is 100. Correct? Now you can see here is a problem. You will get an error because your VLAN would be inconsistent. You are saying my native is 100 and here is not 100. Correct? So ultimately I need to set this particular interface also, it shut down. It discovered that VLAN is mismatched. Correct? So if I say conf t interface fast Ethernet 0/1, it is down right now. If I say switch port trunk native VLAN 100. Okay, the port is restored. Let's see. Okay, now let's see. Now I change my trunk port to understand the native VLAN is not 1, it is 100. Show interface trunk. Okay, it is also changed. Now everywhere we told the router that anyone who is sending the traffic does not have the VLAN tag, whenever it received over here, change that particular tag to 100 because our native VLAN is not 1 now, it is 100. Okay, it's done. Now, am I able to communicate now? Now, this packet would be coming from here. Now, rather sending the one tagging, what my switch is supposed to do, he should put the tagging called as 100. So it should work this time. Yes, it's working. This concept is called as native VLAN. Correct? This is very, very important if you are using legacy devices. It also very important for to avoid the attack called as VLAN hopping attack. Remember that VLAN hopping attack is there. It is also very good that always change the VLAN to the native VLAN. But I remember that in order to understand this, I have done this native VLAN to 100. Technically speaking, in a production side, they will choose such VLAN ID number where none of the port is assigned to that VLAN. Remember that. Only for understanding purpose, I have converted my VLAN from number 1 to 100, where one of the computer is the part of it to understand it. In real life, native VLAN means my default VLAN. I will choose the native VLAN to such VLAN ID where I do not have any port is the part of VLAN ID. Nothing is connected. Correct? For example, I will choose the native VLAN should be 9999. Normally we used to do that 9999 6666. Correct? Why? Nothing is connected to that VLAN. It is not, no one is the part of that VLAN. It is for to avoid this VLAN hopping attack. Otherwise, everybody know that what is the native VLAN number is 1. Correct? And some port is the part of it. So there is a chances that VLAN hopping attack could be possible. So avoid that attack. We need to do this. Correct? I hope it is clear to all of you. Is there any doubt till so far regarding VLANs? It's quite big chapter. We are going to do it step by step. So I am dividing every particular chapter into step by step because these concepts you need to understand. Theoretically, if you start reading the book, there are many things, correct? But practically, if you want to implement it and how it is working actually, this is what we can say. Correct? So I hope it is clear to all. Then we will talk about another interesting topic, which is called as VTP, VLAN Trunking Protocol. Okay. We are also going to talk about VLAN, or you can say VTP pruning. Now, VTP pruning is by default disabled, correct? However, we need to enable it. However, there is a certain condition for that. We will not be able to see practically. However, we will be able to see the concept of VTP pruning. Okay. Let's understand what is first of all VTP. Let me close all this window. The final concept which we need to understand is called as VTP. Very simplified, very effective for bigger organizations. We can see that. Now I will give you one. I think we have already discussed while deciding that which router we are using. We understand the concept of hierarchy, correct? So the concept of hierarchy means, let's say I do have a headquarter, correct? Then I do have city branches, the major cities. Under the cities, I do have multiple branch offices. I said branch 1, branch 2, branch 3, branch 4. Similarly, I do have a multiple cities like that. Correct? Now, based on this requirement, we are supposed to provide the different type of our switch or router solutions, correct? So even in the switches, we do have multi-layer different type of switches. I could say I required a very huge traffic. I should use a very high-end core switches over here, correct? Then I should use median level switches over here. I can have something like median level switches to the city area, correct? And underneath that, for the branch level, I should have also small switches which can be handled. Okay, now you can see this is supposed to be happened everywhere. So if I say here, this is my branch switches, this is my branch switches, this is my branch switches, correct? And now this is only a diagram. I will tell you what is the problem in VLAN in any such like in such environment. Now all these things are connected, correct? You can say these branches are connected. Okay, some sort of like this. Now imagine I do have 50 different departments.
Thanks for watching. Want to study further? Join our training programs today.